Hello, good afternoon everyone, and welcome to my mock lecture. So as introduced, I am TEAH. I'm an assistant professor from these universities. So actually I had been joining Waseda since last April, so not so used to this place at the moment. So this is the first time for me to give an open lecture in this campus. So to make it simple, because it's a 30-minute short lecture, we will discuss a little bit about the concept of sustainable chemistry for humanity. So a little bit background of myself. I'm actually a Malaysian. So as introduced by previous speakers, in this EBSE program, we have people from very diverse background, from Singapore, Indonesia, India, and Malaysia. So I did my undergrad and master degree in environmental engineering in Taiwan. And then later I came to Japan for a PhD degree in sustainability science in the University of Tokyo. So looking at this background, you might wonder, why am I giving a talk in chemistry? So for me, I think people study chemistry for many reasons. And today I will just share you my brief stories. Well, the presentation will be organized in two parts. The first part will be environmental challenges facing humanities. Of course, due to my background or interest in environmental issues. And the second part will be sustainable chemistry as a part of the solution to this big problem. So yeah, without further ado, let's move into part one. So you might be able to hear the sounds, even though it's not so loud. In Malaysia, we have a lot of rainforests. So rainforest sounds very nice with a lot of animals, birds, and stuff. But in recent years, a lot of landscapes has been changed. Has anyone been to Malaysia actually? Yeah, many actually. So when you landed in Kuala Lumpur, the capital city, if you look out from the plane, what you actually see is most likely this kind of sights, right? Sometimes people say it's very beautiful patterns, but behind this is a huge deforestation issue. So people are cutting down the tree to make palm oil plantation. So for me, Malaysian, this is a very big environmental issue facing us. Now, what are the impacts of deforestation of palm oil plantation? Well, if you study chemistry, then you pretty much know a little bit of the science of climate change. So when we cut down a lot of trees, the trees function as a carbon dioxide absorbance in the earth. So when we reduce the tree, we release more and more carbon dioxide into the atmosphere. So due to the structures of carbon dioxide, it's very effective in trapping the heat. So when we had heat from sun, it hits the earth. Supposedly, most of them go out into the outer space. But due to the increase in CO2 concentration, this heat stays in the atmosphere for a longer period of time. Therefore, we are having this very, very hot summer. Okay, so I'm sweating actually. So the other issue is eutrophication. Eutrophication is the terms for excess nitrogen or phosphorus in water. So we are creating too much nutrient to the water. So due to the plantation of palm oil, we use a lot of fertilizers. Fertilizers usually in P or N. Okay? So a lot of fertilizers will go along with the runoff, going to the rivers and increase the phosphate concentration in the water. So what happens is this nutrient is also good for algae. So some algae grow and they grow too much and they compete or they consume oxygen and compete with the fish or any others animals in the water. So eventually they will cause a pond with or a river water with lacks of oxygen. So disrupt the biodiversity. So these are some of the very bad impact happening in my places. Since palm oil plantation or deforestation is so bad, why are we keep on doing this? So can we change our behavior or activities? Now, can anyone tell me why do we need palm oil? In your daily life, what kind of material include palm oil? Anyone? What? Potato chips. Yes, you use to fry potato chips. Yes, cooking oil. Anyone else? Yeah? Nutella? Yeah, you saw from the commercial from somewhere, right? So Nutella did contains this palm oil. So in reality, in our daily life, almost every substances contains certain amounts of palm oil. Okay? So when you wake up in the morning, lots of people bath like me, and then we use the toothpaste. Toothpaste has some contents of palm oil. Your cosmetic products has a lot of palm oil. Your ice cream, your cooking oil, and your detergents, they all contain certain amounts of palm oil. So the main chemical compositions of this palm oil is actually called palmitic acid. So it gets its name from palm oil because around 50% of the contents of palm oil is actually palmitic acids. So this is a very long chain fatty acid. So they contain around 16 carbons. And this is very useful in a lot of modern day applications. For example, if you conduct saponifications, basically adding palmitic acid with NaOH, then you can produce sodium palmitics. So this is actually the main ingredient for cleaning agent, so for soap and cosmetic use. On the other hand, if you go through this hydrogenation process where you add in hydrogens, then you can produce cetyl alcohol from these palmitic acids. And this is used on detergent and cosmetic. So this makes the liquid you use in detergent looks opaque. Now, this is actually not an individual incidence around the world. So we are not talking only about palm oil or Malaysia. So the world is actually changing very, very fast. So from this figure, you can see, this number is a little bit small. So basically this is a year, and the red one is 1950. So after the World War II, lots of things happened. So we have the sharp increase in world populations, increase in economic activities. So you have a GDP increase a lot after the World War II. And as a result, you have very, very different activities is happening. All happens around this 1950s. So as a consequences, our Earth system have to bear more and more loads or environmental loads. In the air or atmosphere, we notice or observe this increase in CO2, as we mentioned before, nitrous oxide, methane, and ozone. So in the water, we also observe we have increasing issue of ocean acidifications, and etc. So even though we just mentioned about CO2, loss of forest, and fertilizer before, however, the globe as a whole is actually experiencing more and more burdens from human activities. So, welcome. So this is a brief image showing the current environmental issues happening around the world. Well, some of the scientists has been proposing a new name of geological epoch in our time. They try to name it Anthropocene. Anthro means human. So this is a geological epoch that dominated by human. So human can change the conditions of planet Earth. Now, we might wonder, so if we keep on our developments, is there a safe boundary that we should not exceed? So if CO2 keep on increasing, is it at some point the Earth will be no longer livable by human beings? So this topic was concerned by some group of very top scientists, leading by Johan Ropstrom in Stockholm Resilience Centers. So in 2009, they first published a framework trying to describe what is the safe boundary for human living on Earth. So here in this diagram, the green, the inner circles, or the green part, is what they define as a safe boundary. So if we have the environmental load within this boundary, meaning we are safe. But on the other hand, if we exceed this, then immediate action should be taken. So here they look into 9 big impact categories related to the sustainability of planet Earth. So we have this, of course, the climate change is the easiest to understand, causing by greenhouse gases increasing. So now we are having around 410 parts per million CO2 in the atmosphere. So the safety boundary should be under 350. Of course, you can see this one is related to the fertilizer usage. So we have too many nutrients going into the water or the ocean. So this safe level is actually defined by the historic observation on planet Earth. So we know that humans thrive because of this stable climate throughout the history. So in order to preserve these stable climates, then this must be preserved. Now, so we know that there is so many categories that exceeding current boundary. But at the same time, we have a lot of peoples that are still living in poverty, say in Africa, so in India. So there are people that need modern accessibility to electricity, to a lot of these AC fancy equipments. So what can we do about this? Now, on part 2, I would like to turn into this sustainable chemistry as part of the solutions. Following the famous report from Johan Rockström, the planetary boundary showing before, in 2018, so last year, they tried to simulate on what condition we can preserve our safe boundary in developing into the future. So 9 is the total environmental boundary that we should secure. So if we keep on business as usual, basically meaning doing what we are doing right now. So Africa keep on burning coal and then keep on building more and more power plant, then we will have a deteriorate impact on the Earth into the futures. However, if we want to save the Earth, then we have to make something more radical or more transformational. So they name it this as transformational change. So in order to reach this transformational change, lots of technology innovation is necessary. Of course, you need innovation from physics, from bio, from chemistry as well. So as a chemist, what can we do? Now, sustainable means, so this is sustainable chemistry. Sustainable chemistry basically bears a goal towards design, manufacture, use of efficient, effective, and environmental friendly chemical products and processes to preserve our environment and sustain human development. So there is no firm definition of sustainable chemistry. However, this is the general concept. So we want to make our current chemical product or production process more efficient and friendly to the environment. Now, in late 90s, so some scientists try to identify the 12 principles of green chemistry, while basically is the basics of this sustainable chemistry. So these are the 12 basic principles. Due to the time limitation, we probably wouldn't go through it. This will take a whole semester-long lecture to discuss. Well, the idea is we need to, for example, prevent waste in the production process, use less chemicals to produce or to synthesize the product we want. Okay, trying to use less hazardous, meaning less toxic materials in the synthesis process. So in this lecture, I will try to show you an examples happening at basically what we are doing right now in Waseda, mainly targeting a design for energy efficiency and using catalysis for productions. Okay, so I will briefly go through it using this example. Now, the material we are interested in developing is called carbon nanotube. Has anyone heard of carbon nanotube before? Yeah, cool. So what do you know about carbon nanotube? Anything? What can we use carbon nanotube for? Wire, yeah, true. Because it is very strong. Okay? So carbon nanotube is a very, very specific arrangement of carbon. So imagine one dot is one carbon. So if we can arrange first scientists discovered the structures of graphene. So when carbon arranged in this form, you produce these very strange materials called graphene. And graphene was awarded for Nobel Physics Prize, I think, in 2010. So for this graphene material, if you roll it up, it becomes a tube. So this is called carbon nanotube. Now, why we are interested in carbon nanotube? because this material is very unique and it possesses many useful properties. Well, for example, it is very, very strong, 10 times stronger than any industrial fiber we exists on the Earth right now. So imagine you want to make an elevator connecting to the moon, then you need something very strong, and this maybe in the very, very far future, this might be an option materials for that. And this carbon nano CNT is also has very high current carrying capacity. So as she mentioned just now, CNT can be used for wire because you can transfer or conduct electricity much faster than the normal wiring equipments. And this also transfers heat very fast, okay? So it is much more faster than aluminum, for example. So for having those very unique and useful properties, when we talk about the transformational change mentioned earlier, what we need for technology innovation, then CNT becomes something very interesting. So one of the major content of transformational change is we should accelerate our renewable energy growth. Okay, so one of the key issues right now is modern human life depends on energy, and energy currently mainly comes from the fossil fuel, and fossil fuel burning is causing a lot of stress. So one of the key components to change is the renewable energy. Now, the most common approach is the solar cells and battery storage, because solar cells we don't have sunshine 24 hours. We only have like half a day for sunshine. So to use solar cells in our society more comprehensively, then we need very good corresponding battery storage. So you have to store some electricity. Now, currently, this is very fast developing. The price goes now very fast. Solar cell right now, even though it's not as cheap as coal, but it's getting closer. And a lot of issues come from the efficiency of solar cell and also the production of solar cell. So we can use very different types of materials to produce it. And CNT, due to this characteristic, we can use it as a transparent conductive film, so one layer on top of these solar cells. And using this CNT, because of the lightweight and the characteristic, we can make our solar cell much more thinner and much more efficient. On the other side, this is the structures of battery. In current battery, there's a lot of not unnecessary materials contained in it. So in order to improve the efficiencies, then this black line is basically CNT. So you can improve the conductivity and capacity by adding this carbon nanotube as a bridge in the structures of battery. Now, we hope that in the future, if CNT can be mass introduced to this innovation of renewable energy technologies, we can partly solve the problem of climate change. Well, right now, the big problem is this is very expensive materials. Now, for 1 gram of CNT is around $800 to $400 US. So we are talking about more than 1 million yen for only 1 gram. Okay? And there's a very high environmental impact in the production process. So can sustainable chemistry provide some solutions here? Or can we design the CNT production with the green chemistry principle? So first, let's try to understand how CNT is grown. So imagine this is a reactor, and these two are the heater. First, to grow the CNT, we need a flat substrate with some nanocatalysts. Okay? So this can be aluminum oxide substrate, and these usually are iron nanocatalyst particles. Okay? And then first we have to, after preparing this substrate, we have to heat up the reactor somewhere close to 1,000 degrees Celsius. So you can imagine this process is very energy intensive. And then at this high temperature, we started to flow in some hydrocarbon. And argon gas is used to carry the gases into the reactor. So at a very high temperature, this C2H4, for example, will break down and they become carbon. Okay? So due to this nanocatalyst, then carbon will grow and H2 or H2O will be flow out. So this is the very basic concept of making CNT. So how can we improve this? these CNT production material methods. So in the lab right now in Waseda, in Noda Hanada lab in applied chemistry, so we are developing different innovative approach or different technologies to trying to bring down the impacts of this carbon nanotube production. So, well, this is a bit busy graph. So to make it simple here, this is the CO2 impact. So the higher is the worse, and these are different scenarios. So this is the scenario I introduced before. So currently we are having very high CO2 emission for producing the carbon nanotube. So the goal is to bring this as low as possible. So from chemical engineering perspective, then what we can do, for example, the first step, we might change the reactor into different production methods. For example, in these cases, the energy used depends on how many substrates you can put on into this reactor. So it can only grow on the surface, so like growing on the surface. So this is like a two-dimensional growth. So a lot of space is wasted. So one innovative way is we can try to make this into like a fluidized bed reactor. So in this case, the substrate float in the reactor. Therefore, this space is better utilized, and CNT can grow in three-dimensional condition. In this case, we can increase the yield significantly. So therefore, the first impact will the first innovation will reduce the CO2 to much lower levels. On the second case, we try to change the catalyst deposition methods. While we use radio frequency magnetron sputtering before, and then if we try to use it in these certain CVD methods, then we can make also the impact much lower. Sorry, I think this is, yeah, maybe I can quickly show you the video. So this is actually how the CNT is actually growing in this fluidized bed reactor. So we have carbon source going in, and then argon pushing those material. And the black spot is actually the CNT growth. And on the other side here, you can see when this moves up, and then there is more and more carbon nanotubes that grow and can be collected in this flask. So, of course, this will significantly improve the productivity. Well, in the third cases, previously we used a lot of argon gas as a carrier gas because this is more inert, so it does not react with the chemicals we want. So, however, production of argon is very energy intensive as well, because imagine in the atmosphere we have only less than 1% argon. While on the other hand, the most abundant gases on the Earth is nitrogen. So can we try to use nitrogen to replace argon? So if this happens, then we further reduce the impact. Now I know this sounds a little bit far beyond what you would do in these undergrad studies, but yeah, in the future, if you join Waseda, then you will have a chance to work on these types of experiments. So in summary, in part one, we discussed the environmental challenges facing humanities. I used the case of palm oil as a beginning for my own motivations, and I introduced the safe boundary for planet Earth. On part two, we discussed the concept of sustainable chemistry. So this is a new concept proposed by chemists and mainly based on the green chemistry principle. And then right now, we have some examples of trying to demonstrate this concept through our CNT production experiment. So in the end, I pretty much welcome you to join the EBSE program. Let's learn the basic and even the advanced chemistry knowledge and try to apply knowledge for problem solving. More importantly, yeah, we should always try to care for the environment. And yeah, since I have like 5 minutes left, I would take any question if you have, or if you want to send me an email, it's always welcome. Thank you for listening. Right. Is there any question? Anything is fine.
What are you studying?
What am I studying now?
In relation to the CNT, are you doing something?
Yes, I'm actually from the background of environmental management or environmental impact assessment. So in the experiment I showed you before is conducted in Noda lab. So Noda sensei is famous in making this CNT. And so most chemists work on technology development. So they want to improve the efficiency. They want to try different catalysts. They want to try different conditions. They do a lot of experiments. At the same time, they do not aware or do not have knowledge to quantify the impact for CNT, environmental impact, what we are talking about. So mainly they hired me to help in making assessment on their new developed technology. So I basically use some methodology. For example, how can we know how many CO2 is emitted for this production process? So behind this, there is a lot of different methodologies. The main methodology I use is called life cycle assessment or LCA. And yeah, so in daily life, I do LCA for different technologies and try to help and communicate the impacts for chemistry technologies. Thank you. Yeah. In this case? Yep. So in this case, I think a lot of testing has to be done. Like you have to try in experiments. So basically, the purpose for this is for carrying the hydrocarbons or sometimes the catalysts. So as long as they don't react with the hydrocarbon we wanted, then as long as it doesn't affect the growth of CNT, then this can be happens. Okay. So, well, yeah. Thank you. Very good questions. Okay.
If there are no more questions, we'll end the lecture for today. Thank you so much, Professor TEAH, for the very contemporarily significant lecture. We'll have a short break for around 12 minutes or so before the next lecture on civil environmental engineering issues. So if you'd like to stay around for that as well, that'd be great. Thank you very much.